Anyway, so I think we can start. So hello, everyone. Good afternoon. My name is Erico Matos. I'm the Executive Director of the Greenhouse Lighting and Systems Engineering Consortium, and I will be your host today. So for those of you that is the first time, we are holding one more session of the GLAZE webinar series. For those of you who have been before, hello and welcome again. And it is my pleasure to introduce today's speaker, Dr. Selena Gomez from University of Florida. Dr. Gomez will be talking about the stakeholder needs relevant to indoor propagation. So that's a new topic for our webinar. Dr. Selena Gomez is an assistant professor in the Environmental Horticulture Department at the University of Florida. Her research focuses on developing innovative production systems for the controlled environment agriculture industry, with an emphasis on optimizing economically viable practices for greenhouse and indoor production of ornamental and edible crops. Her current area of research includes plant responses to sole source lighting, indoor gardening, and indoor plant propagation. She is the state representative for two multi-state groups that translate research outcomes to stakeholders. One of them is the NSERA 101, which stands for the Committee on Controlled Environment Technology and Use, and the NE 1835, which is the Resource Optimization in Controlled Environment Agriculture. Dr. Gomez is also serving as the chair for the NE 1835. A record version of this webinar will be available at the GLAZE website afterwards. And if you go to glaze.org, you'll be able to find not only this presentation, but all the other presentations we have done so far. And you can also register for the upcoming ones. We have already scheduled all the webinars from now through December. So take a look, you might find some ones you might like, and I'll be seeing you again over the next few months. If you have any questions about the presentation today, would like to get in touch with Selena or myself, please use the Q&A box at the bottom of your screen. We will do the best as we can to answer all the questions by the end of the presentation. And if we cannot go through all the questions, I'll send everything to Dr. Gomez afterwards, and then hopefully we can get all of those response by email if necessary. Well, with that said, Dr. Gomez, it's a pleasure to have you here, and you're good to go.
Perfect. Well, thank you so much, Erico, and thanks everyone. I see there's 42 attendants, which is fantastic. I know that there's several things going on today. There's a conference. I just attended a very good webinar by Dr. Mark Van Eersel, and now there's this. So thank you all for taking the time. And today I'm essentially going to go over part of the research that we have here at UF on indoor plant propagation. Most of today's presentation will be focused on results from a project that was led by Dr. Alexa Lam from the University of Georgia, part of an SCRI planning grant that we got last year. This indoor plant propagation program is co-led by my colleague Paul Fisher here at UF, myself, and we have a couple of colleagues at North Carolina State University and Texas A&M as well. And towards the end of this presentation, I'll also go over a few results from some of the research we've been doing in the past few years that have been led by a few of the students here at UF. So just to get started, I'm going to go over just a few slides to introduce the program that we have on indoor propagation. And I'm going to start with just showing some of the characteristics of indoor farming. Some people call them plant factories, vertical farms, just controlled environments. And what I want to highlight with this slide is just the diversity of the industry that we have. I mean, we can see some growers who use a typical growing bed. Others are now using vertical systems, vertical production systems. Some use hydroponics, some use substrate-based production. We can clearly see from these pictures the variability in the lighting systems that are being used by some of these growers. And just overall, just want to highlight how the industry is very diverse, and what works well for some growers might not necessarily be the best approach for others. So here I've listed some of the advantages of indoor farming. And I'm sure everyone who's connected today has already heard some of the benefits that I have in here, perhaps a few others. Um, all I want to point out, though, is that most of these advantages apply when we're comparing indoor plant production with field production, but also some of them with greenhouse production because of the variability in growing conditions that growers can experience in a greenhouse. So instead of going over that previous slide, I'll just jump straight ahead and just talk about the different crops that can be grown in controlled environments that are suitable and economical to be grown in these indoor farming systems. We all know that ideally we should be growing crops that are have a relatively short height to maximize that space use efficiency, that have a short production cycle as well, so that we can either produce many more crops per year within the same space, or just minimize the production costs for growing these plants. Typically, we want to grow crops that have a high harvest index, which is generally, well, it's one of the key reasons why leafy greens is one of the key crops. Different types of leafy greens are just commonly grown in these indoor farms. If we compare a lettuce versus a tomato, most of what we harvest with a lettuce plant can be sold versus when we grow a fruiting vegetable, we're really producing a lot of biomass, and a lot of it is not necessarily going to lead to a profit. We want to grow crops that have a year-round demand, and ideally have lower inputs. This really should be low inputs. With light, for example, we want to grow something that won't have very high light requirements, but the same applies to labor or handling requirements, fertilizer and water as well. And lastly, we want to grow crops that have a high value, and plants or crops can inherently have a high value, or we can provide value-added qualities to these crops being grown in this indoor environment. So those are just some key characteristics to keep in mind. Now, briefly, I just want to go over the current status of the industry. So far here in the US, most of the indoor farms have been focused on growing leafy greens or herbs in this indoor farming facilities. And part of the challenge with that is that there is a big competition with field crops that are grown for a much lower cost in states like California, for example. And this is very different from the situation that growers face in countries like Japan or Korea, for example, where land is limited and consumers are willing and used to pay premium prices. Just yesterday, I was reading a report on how consumers in Japan are very picky, and they're used to paying and willing to pay these premium prices, and that's not necessarily the case here in the United States, unfortunately. Starting to rain, so I may have to close my window in a minute. But anyway, I'll just go on. I've listed a few other things. Unproven technology, which leads to uncertainty. That is one of the challenges that a lot of the growers have faced. Layout and system inefficiencies and lack of training resources. Those have all been highlighted as challenges that the producers here in the US have faced. And these last this last bullet points actually came out from a meeting that was held a few years ago at one of these vertical farming conferences. And it was a panel by some of the executives in some of these indoor farming facilities that struggled, and some had to close their doors at that time. So these challenges are essentially the reality for the industry here in the US so far. So what we've done here at UF is try to use this vertical farming systems with these controlled environments in a different way, essentially to provide an alternative to help growers, plant propagators here in the US who have challenges with growing young plants, which include seedling blocks, rooted cuttings, tissue culture propagules, using commercial methods, most commonly grown or produced in greenhouses. And as I'll explain later, there's a potential to leverage some of these indoor farming systems to improve some of these propagation practices. At the bottom of this slide, I've listed some of the characteristics of young plants, and we can see that essentially they share a lot of the qualities that I mentioned earlier on some of the important characteristics that are needed for successful indoor plant production, right? Short height, short production period, low energy demand on a per plant basis, high economic value. So I'll briefly go over some of the current plant propagation practices, and I'll focus on vegetative production or propagation of cuttings as well as tissue culture plants. There's other groups that are using these indoor farming systems to propagate seedling crops, and here at UF we're particularly focused as of now on using these systems to propagate unrooted cuttings and tissue culture plants. And so we can see this picture I took earlier this year in one of the farms in Guatemala, where a lot of the stock plants or the mother plants are grown to harvest cuttings that are then shipped here to the US for propagating in large-scale commercial greenhouses. At the bottom, we can also see a picture of tissue culture plants. It's actually a picture of heuchera plants that we just got, and heuchera is one of our model plants right now because it's one of those plants that can be problematic when you move those plants directly from the laboratory where they're micropropagated to the greenhouse. So essentially, the greenhouse is not necessarily or not always the ideal environment to propagate high value transplants because it can be highly variable in terms of the environmental conditions, and it can also be expensive, and it becomes more of a challenge when growers experience high shrinkage or high losses from as a response of this highly variable environment. And so we know, I mean, growers know that in order to get more uniformity, a controlled environment can be useful, and it's common for a lot of these commercial plant propagators to have especially those that propagate plants using seeds, to have a germination chamber, a controlled environment where they get that high uniformity, and then plants are moved after a very short period of time to the greenhouse to be grown out. So essentially, that's part of what we're trying to do. I just want to make it clear that the research we're doing is not necessarily trying to tell growers to change their existing production practices. It's really trying to provide information on the possibility of integrating another step into the production processes that can minimize some of the losses, or can potentially reduce the production time, or can potentially improve the quality of these transplants that are being commercially grown by them. And this being an intermediate step between the laboratory, for example, and the greenhouse environment where these plants will be propagated. So very recently, I think late last year, there was in one of these grower magazines just a very short, nice article that was highlighting how indoor propagation is expected to increase within the coming years, but particularly for greenhouse finishing, where there's a lot of potential to, again, improve some of these existing practices. So very briefly, I mentioned we're focusing on the acclimation of plants that are grown in using tissue culture techniques. You can see pictures here of blueberries, which is one of our model crops. And you can see how there's a potential to have significant losses. I mean, this is a picture we took in one of the propagators here in Florida. And when each one of those plants costs close to $1, and you have close to 70% losses within a tray, which is what a lot of the propagators here in Florida have or experience, it becomes a significant problem that needs a solution. Also on rooted cuttings, I mean, we know that the environment, these are very delicate plants, and they have very specific environmental requirements with regards to the light that they can tolerate and the humidity that they need. And those things may lead to problems. There could be disease development and also algae growth, which is something we've experienced with some of the research we've done. So there's potential to improve these two propagation processes. There's a few growers here in the US that have already adopted, and I see that at least one is connected to this webinar. And Shenandoah growers, for example, they have very impressive high-tech facilities that are used to propagate plants in controlled environments and then moved into the greenhouse. This is particularly for air propagation. And then there's others like Battlefield Farms that have a much simpler system. It essentially consists on it was a retrofitted cooling chamber where they just put this lighting racks and plants are moved in and out in little carts. And it worked great at reducing or eliminating a problem that they had, which centered around shrinkage. They were losing a lot of plants when they were trying to propagate this TC, tissue culture transplant, and just move them directly to a greenhouse, and having this transitional phase essentially eliminated that problem. Other growers like Metrolina are also adopting some of these technologies. And then Frontier Lab, which is a picture from, I believe, South Africa that my colleague Paul Fisher took. And you can see that somewhat, I believe that they're using something similar to a dome to maintain that humidity within that propagation environment, and just using white light. So now I'm going to go over the study, this planning project that we led last year. Essentially, the goal was to better understand the needs for research and for education that a lot of the specialty crop growers and other stakeholders have, and their potential interest in supporting indoor propagation. The first thing I want to clarify is that for this research, we use purposive sampling. And that is because as of now, indoor propagation relies on an emerging technology, and it's currently only used by a small group of early adopters. And so there really is a limited recognition on the potential benefits of indoor propagation by most growers. So we decided to specifically target our survey and our focus group and get information from people who we knew were at least aware of the potential benefits of indoor propagation, and or potentially had experience with this indoor propagation environments. And so the survey enabled us to collect quantitative data. The focus group enabled us to collect qualitative data and more in-depth analysis and a better understanding of some of the priorities and some of the qualities of indoor propagation that these growers would consider. And so for the survey, we essentially invited 20 different specialty crop growers, and these were all growers who had at least 100 that produced at least 100,000 transplants per year. And we provided them with 19 different questions, and I'll go over some of those results next. For the focus group, instead, we reached out to 25 stakeholders. Now, for the focus group, however, we did invite people who represented different aspects of the industry. So we had, of course, growers who use indoor farms for edible crop production, growers who use indoor propagation systems, but we also had participants representing breeding companies, lighting companies, substrate companies. So it was a much more diverse group, but people who would all ultimately be key players of this industry. And so this, again, was led by Dr. Lamb. She was the moderator for the focus group, and we had a couple of her staff assisting. All three of them had never had any relationship with the people present, with the participants of the focus group, and that was in order to reduce any bias. In fact, two of our colleagues who were part of the academic group had to step out of the room so that we could ensure that the answers or the discussions within the room were not biased by the presence of having two experts within or on propagation or horticulture in general present. So I'll go over some of the results. For the survey, we had a 65% response rate. We received response from people representing 5 states in the US and someone from a different country. Most of them were college educated. In fact, half of them, or over half of them, actually had a graduate level degree. And again, almost 60% had annual sales between $10 million and $250 million. And of the 13 respondents of the survey, we found that 61% of them had already experienced with indoor propagation. And those, most of those indicated that they needed at least 5 people to maintain or maximize the benefits of this indoor propagation environment, which highlights the potential to start integrating some mechanization or automating some of the processes with propagation. Overall, the participants were interested primarily in tissue culture acclimation in these indoor environments, followed by seedling production and then cutting propagation. Regarding the plants that were of interest, hemp came up as one of the potential crops to be included in research. A lot of ornamental plants. And I'm sorry, I skipped it, but in this slide, you can see at the bottom that this paper actually was recently published in Hort Technology. And there you can see a list of all the crops that were really listed as potential model crops, let's call them, to be used in this indoor propagation research. And that's really because growers essentially experience challenges when producing these plants. And there's a list of about, at least I'd say 20 different species that could be potential model crops for this type of research. And of course, leafy greens, which was of interest. And I'll provide more little details about this towards the end of the presentation. Now, 88% of the users of indoor propagation environments indicated that they use LEDs. However, the reported intensities of light that were used by the growers ranged between 15 to 6,000 micromoles per square meter per second. So when we looked at this data, this highlights to us the need to provide information to educate growers so that there's a better understanding on the different units that can or are used to describe light used for plant growth and development. And that is because this is a very unrealistic range. I mean, according to the literature, a more realistic range to propagate plants can be from 100 to 300 micromoles per square meter per second, but even less than 100 micromoles is really not uncommon. So now I'll go over a few of the results. I've just taken a few of the tables from the paper. This shows the importance of the factors that have driven adoption, particularly for a lot of the growers who have already decided to adopt this technology, but also what would be a driver of adoption by those that hadn't. And so overall, I'd say the most important factor driving adoption was shrinkage, was that motivation to reduce the losses that the growers were having with their existing propagation practices. Also increasing the ability to produce more plants per unit area, improving or speeding up really germination or rooting processes. Of course, providing details about the economics, essentially benefits about the economics, integrating the systems and potentially leading to higher profits and improving overall plant quality. Another thing that was of interest, though, is that automation was listed as the least important factor driving adoption, which is particularly interesting because if we see here, labor efficiency, improving labor efficiency was really the sixth most important driver for adoption. But it seems that just the fact of implementing automation is really not something that the growers are particularly interested. So overall, this shows that, and we've actually made some calculations, and this is based on published case studies from Asia about the potential economic benefits of using indoor farming for leafy green production, and comparing that with reducing shrinkage, just reducing shrinkage using indoor propagation environments, there is a high potential to increase the return on investment compared to leafy green production again. And then if we consider the potential reduction in the production cycle, then that becomes even more significant. So then we asked about the perceived advantages and challenges of using these indoor propagation environments. This was more of an open-ended question. And some of the advantages are listed here. Overall, growers see the increase in uniformity and maintaining year-round quality as the two most important advantages. And really, those two go hand in hand, I believe. And again, this reflects the challenge that they have with maintaining quality with that seasonal fluctuation that they can get in a greenhouse. Better space utilization, improving profitability. This all essentially reflects a lot of what I previously discussed on that other table. Reducing production times. And what was interesting, we see here, reducing pest breakouts was an advantage, but potential problems with disease pressure is a challenge. And that's the true. I mean, we've seen it with some of our research. Things like algae growth can become problematic in this indoor propagation environment. So a lot of the research on plant health overall will become critical within this indoor propagation space, I believe. Another challenge is that growers believe that there will be a steep learning curve in adopting some of these technologies. Environmental control and management can also be a challenge. Also, particularly understanding the interaction of these different parameters, light, and how changing something with light will affect temperature and the humidity within the production environment. So those interacting environmental factors and understanding how those affect plant growth and development, they think might be a challenge. Need for ongoing maintenance and need for space, which is again something important to consider, because growers are wondering where to put this indoor propagation space. And that's again going back to what I'll mention later, and going back to the system that Battlefield Farm had with the moving light carts. That might be a solution for this challenge. So I'll go over some of the priorities that were identified for new research. And we see economic costs, proving the economic benefits of the systems, and having research that shows a return on investment from implementing the system is number one for growers. So research evaluating the economic potential of the systems is really the first priority by people who participated in the survey. The effects on crop quality, production time, uniformity, and shrinkage would be secondary. Light management was also really important. And as you'll see next, this came out in the focus group discussions as well. And that's good, because a lot of the ongoing research by our group and others is as of now focused on that. Interesting though, here we see that automation was one of the priorities that the growers identified that should be researched more. And however, as we saw earlier, they weren't really necessary in adopting automation or adopting this technology just to adopt automation. So that was interesting. Another thing that was of interest to us is that the development for training materials for staff was actually listed as the least important priority by the people who participated in the survey. And that's a bit shocking to us. Just because, I mean, we heard it last week in the excellent webinar that was provided by Cornell. And I mean, there is an importance, there's a need to develop these training materials for the people who are working in this area. But among the options that we gave growers, that was really listed as the least important priority. And I guess it might have to do with the fact that this were listed as priorities for research, and training for staff is really perhaps a priority for extension or outreach efforts. So now I'll go over some of the results from the focus group. We had, again, 29 people were invited. Of those, 19 participated, which is, I think, a pretty good response rate. We all met last year and had a 3-hour session, I believe. And I'll just jump straight into some of the results. We see it once again. Cost and return on investment were really some of the most important research needs or areas that are critical for research according to the participants of the focus group. Light management, crop quality, production time, reducing uniformity, reducing shrinkage. I mean, improving uniformity and reducing shrinkage. So I've highlighted those because that's exactly what we saw in the results from the previous table. And then environmental control and management is also something that that is key. And that's really where, again, a lot of the research so far has been focused on environmental, particularly light management within these indoor plant production environments. So a couple of considerations. First, I'll go over the crops that were discussed as having potential to be used as model crops for research. Again, leafy greens and hemp came out, and there's no particular order for what I have listed here. I just put hemp first because I want to highlight the fact that yes, it came out once, and then again in the focus group responses. However, there are existing limitations at the moment for what we can do as researchers with hemp. I know that there's a couple of groups, at least here in the US, that are already working in hemp propagation. For us here at UF, we are exploring those that opportunity, but there are limitations to what can be done with hemp as of today. Having said that, though, there's a lot of opportunities to use this indoor propagation environments for other medicinal plants. I mean, there's a lot of limitations with the existing propagation practices with a lot of the medicinals or phytopharmaceutical crops, and having the uniformity and the consistency within these indoor environments can be key for that industry. Again, with leafy greens, I want to highlight this because I still remember on the conversation how one of the people present in the panel mentioned that of course leafy greens are important, and it's not necessarily what I had in mind, but this person is absolutely right. That's because, I mean, as of now, most of the crops that are being grown in these indoor farms are leafy greens. So doing research that addresses the propagation of leafy greens is of course important. And then there's a few other crops. Blueberries, as we see, is one where growers struggle. And so it has been and will probably continue to be one of our model crops. And then I want to just focus a little bit more on these challenges. That's because I think this is key, and this is what makes research on indoor propagation slightly different from research focused on essentially anything that has to do with crop production in indoor farms. That's because most of the research for leafy greens, let's just use leafy greens as an example, typically uses maybe different cultivars, but essentially a species where we're trying to identify environmental requirements, light requirements, for example, that can maximize growth or maximize quality. And how indoor propagation is very different in the sense that growers have hundreds of species that have very different requirements, that have very different morphologies, that have very different rooting periods. And so there's a very, it's just a very diverse cropping system compared to what we're used to, or what most people are used to with using these indoor farms for leafy green production, for example. And another thing to consider with regards to this diversity is that the benefits from using these indoor propagation environments will be different for a crop where we need to reduce that shrinkage versus a crop where we can provide production advantages in terms of improving quality or in terms of reducing the cropping cycle. And so those things, those considerations will essentially drive the economics and the potential economic benefits of using these propagation environments, which is something important to consider. So perceived advantages and challenges from the focus group, we found that they were interested in just maximizing year-round production, increasing yields, and producing more uniform plants. But we're worried about the cost of using these indoor propagation environments and also the efforts to manage multiple environments. There were comments about concerns when people think about optimizing the environment within a controlled environment, a large production facility versus optimizing the microenvironment where we have plants growing. And that's something that the growers perceive as a challenge. So overall, the conclusion, I think, from the work that we did in general, I believe that this confirms that there is a perception among the people who participated in the study there's a clear perception that these indoor farms will lead to more efficient, more uniform, and high quality transplant production than what growers can get in greenhouses, that there's limitations to propagating plants in greenhouses, and growers clearly see the potential benefit of using indoor farming systems. Regarding stakeholder interest, there's interest in obviously reducing costs, which I apologize, I forgot to include it on this slide, but also improving crop quality, uniformity, reducing crop time and shrinkage, and optimizing the light environment. And regarding the priorities where this technology should be used, or where we could gain more from using these technologies, we should focus on crops that have a high crop loss rate or high shrinkage, or that have either very poor or very variable quality, very variable rooting or growth when grown in greenhouses, or overall slow rooting, where we can essentially maximize the benefits from using these systems. So with that, I'll jump straight into some of the results. I'll essentially switch gears a little bit and just go over some of the research that we've been conducting here at the University of Florida. This is one of our initial trials with indoor propagation. And for this particular experiment, we were growing blueberries, propagating blueberries, which, as I mentioned, are challenging, can be very challenging. And for this trial, we had different intensities that range from 35 to 140 micromoles per square meter per second indoors. We also had one treatment that I call increasing light, where essentially plants were grown under a very low intensity for the first 4 weeks, and they moved to a higher intensity towards the end of the propagation period during the last 4 weeks. We also included 2 greenhouse environments. One was our research greenhouse over here, and also a commercial greenhouse, which was in collaboration with the group in AgriStarts in Apopka. And they're really the ones who propagate this blueberry plants in the laboratory, and then they move them to the greenhouse, and they experience a lot of mortality, a lot of shrinkage. And so we essentially asked them to just continue their propagation process as normal, and to help us maintain the plants and perhaps collect some data, which I'm showing some here in this next slide. Overall here, I'm showing you results for shrinkage, which were just at the end of the trial after 8 weeks of propagation. And the lower 2 graphs show results for biomass, shoot and root biomass. And the black dots, I mean, represent data collected at week 4, and the white circles represent data collected at the end of the trial at 8 weeks. And so what we see is that there's several things to highlight from this graph. So I'll just go step by step. I'm going to start with shrinkage. We can see that overall, in our greenhouse environment, in our indoor environment, I mean, we had very low shrinkage. When we compare that to the greenhouses, either our research greenhouse or our commercial greenhouses, those were higher. 17% shrinkage in a commercial greenhouse is actually not that high compared to what growers in Apopka can actually get. And that again highlights the variability of the results we can get in the greenhouse. I mean, right now we're conducting some experiments, and we've had a relatively mild summer, and so we are not necessarily seeing low yields or low rooting in the greenhouse. However, this can change very quickly, and those results for the greenhouse can be very different. And again, that highlights the variability and the lack of uniformity that a grower could experience when relying only on greenhouse propagation compared to what we know we can get indoors. So regarding biomass, there's a couple of important things. One, we found that the 2 treatments with the highest intensity overall, especially at week 4, had more biomass compared to anything else. So this is important because some people believe that we can only use very little light at the beginning of the propagation process, and we proved that we can actually use double what's commonly used for propagating these blueberry plants, and we can maximize that growth and development. And the most interesting finding, I believe, from these results is that at week 4, the root and the shoot biomass that we had obtained from plants grown under those two higher ppfs was actually higher than that was ultimately produced in the commercial greenhouse, meaning that those growers produced these plants for an extra 4 weeks without gaining anything in growth, whereas we significantly saw an increase in growth at 4 weeks. Meaning that we can essentially reduce the production period of those plants, or get plants at week 4 that would be similar to what a commercial grower is getting at week 8, which is, it's very important. Now, for that same study, we did find that the leaves of the plants had actually accumulated more, had essentially what we believe is anthocyanin. We really didn't measure it, but it's most likely an accumulation of anthocyanin, which most likely is a response to stress, to high light. And 140 micromoles is not really that much light. It's not really a whole lot of light, but it seems to be inducing this response. It's increasing growth, but it's also inducing this response. So part of the research we're conducting now is actually evaluating treatments where we can maximize that growth, but prevent that change in pigmentation, assuming that it may negatively affect some of the potential growth of these plants. And then you can see here some of the, just a comparison of the plants grown indoors versus in the greenhouse. So right now, my PhD student is working on a trial looking at light quality effects, and we're growing different species for this particular trial. And essentially part of the focus is to try to see if we can maximize or induce early rooting within the plants, and also minimize some of that coloration that we were seeing with the higher light intensities. Another trial that we recently concluded was comparing our indoor propagation environments versus using trays and domes and putting these plants in a light cart, and comparing that to greenhouse propagation. And this goes back to the comment I made earlier that we believe this actually might be a realistic application of this indoor propagation systems by some of the growers, where they can just use it for the plants or the species where they have problems, which may not necessarily be everything that's grown in a particular production facility. So some results from that trial, we see here 2 different cultivars of lavender, and in general, rooting was improved when the plants were grown indoors. For this particular cultivar, we see higher rooting and more growth when the plants were grown using the light cart. But perhaps for this particular cultivar, just the regular indoor propagation environment produced overall better rooting and growth. We can also see differences in rooting for campanula here, compared to the plants grown in the greenhouse or propagated in the greenhouse, which is actually pretty interesting. Another thing to note, though, is there is high variability when using unrooted cuttings in particular, but also sometimes tissue culture plants. So that is another reason why these propagation processes can or should be improved, because that inherent variability is a challenge for growers and may sometimes represent losses for growers. So reducing those losses is something that we're trying to achieve with this research. Now, my colleague Paul Fisher sent a few of those light carts to several greenhouse growers here in the US, and so they all have them on site. Some have been doing tests, but our goal really is to actually use some of the funds from this SCRI planning grant so that we can conduct a coordinated grower trial. We're right now hoping to have my student travel as soon as travel resumes after the COVID pandemic, so that we can start this coordinated trial to try to obtain some feedback on perceptions, limitations, and perhaps yield potential of using these systems with for different propagation purposes. And lastly, this is my last slide. I really just want to leave you with with the fact that we're trying long term, we're really trying to understand the limiting steps of the limiting physiology of these plants. And again, I want you to understand, and I have here pictures of poinsettia cuttings, that these plants cuttings in particular don't have any roots when we first start this experiment, so their capacity to take up water, to take up nutrients is limited. And so when we try to optimize light or optimize temperature, when the plants can't really make use of that optimal environment, that can be a limitation. And our goal is to maximize production within this controlled environments. We believe we should be able to do that, but first, I think we need to really understand the physiology of these plants to know how much of each one of these environmental parameters we can, how we can actually push these young plants to optimize this propagation processes, essentially. So that's all I have. Thank you all for your attention.
Hello, Selena, can you hear me?
Yes.
Okay, perfect. My connection got flaky just for a second, right at the end of the presentation. All right. Well, thanks for the webinar. Very interesting, lots and lots of information. We do have time for questions. So let me bring my screen up here now and take a look at the Q&A. We have something in the Q&A. So and I do have a few questions as well. So we have one already in the Q&A box, which is, what light LED fixtures brand model are equipping your light cards?
We're using Fluence. I really don't know exactly what model, but we're using light lamps from Fluence, and they're different. The light cards actually have a different spectra than what we use for our indoor growth chambers. And I really can't remember what the exact model is.
I guess the most important question is, what is, it's a white full spectrum LED?
Full spectrum. Most of the research, even the research focused on like quality that we're doing right now, we do it with a white background because I mean, that's more realistic, I believe, to what growers will be using. And so we're still able to find responses to like quality by having a red biased spectra, for example, but always with a white background. Yes.
Perfect. We just got another question, which is follows up on something that I was about to ask as well. What is the recommended DLI for propagation of microgreens and lettuce? So that's one specific question. But I would like to tie that up with the information that you provided, that you saw people reporting light levels all the way up to 6,000 micromoles. That's super high. I haven't seen that before. So if you can answer this specific question, if there is a specific answer for that, and then what do you think the reasons are for this very broad range of light intensities being used today?
So to answer that last part of your question, I believe that that's probably a mistake. I really don't think that anyone's using 6,000 micromoles per square meter per second of light. And that's, again, going back to the point I made, just to highlight how perhaps whoever answered that question and provided that information, I mean, it could have easily been a typo, but most likely was there's some sort of misunderstanding on the different units, and they might have been thinking of foot candles instead of micromoles per square meter per second, for example. Regarding the first question, I really don't know what's the optimum DLI to propagate microgreens. I've never worked with them, but I'd be happy to look it up and see what it is. It's probably low. I mean, but I really don't know, and I can't answer that question.
Perfect. Another question, interesting one, which is there any application of, I believe it's artificial intelligence in greenhouses and vertical farms? And then again, if I can tie this question of the artificial intelligence with the automation information that you found, I thought that was interesting as well, the low level of interest in automation. So have you considered, so have you included artificial intelligence was part of the automation? That'll be my follow-up question. And maybe what is the level of automation already existing in greenhouses? Do you think, and indoor propagation systems, do you think they're not interested because they already have automation in place? Could that be one answer?
No, I think, and this is when I was helping write this article, one of the things I came across was the fact that part of a challenge with integrating automation with indoor farms in general, I don't think it's indoor propagation, but with indoor farms in general, is that a lot of the technology that um, has been developed for a specific scenario, for a specific farm, and therefore large scale applicability um, is not, I mean, we really don't get that information. A lot of the R&D as well, or applications are maintained within the different companies, and so widespread information on what should or could work regarding to automation may not necessarily be available, I think, at the moment. And I can't recall what was the first question.
First question was if you saw any AI application in greenhouses, vertical farms, which is
so we've gotten questions about it. I really don't know if there are any at the moment. I guess I'm not the right person to ask that question. We've definitely gotten questions by some of our stakeholders here in Florida, and I do think there's interest for sure. But again, I mean, automation being limited, I'd imagine that AI is also limited. I mean, there's increasing interest for sure, but the actual research might be limited.
And that's a good segue for a question that I wrote down here during your presentation. You mentioned the ROI, so the return on investment is a big factor for growers to make whether they will implement those techniques or not. So my question is related to that. They are looking for ROI information coming from researchers, or they want to see their peers. They want to see another greenhouse, a commercial case study where they see this payback time or return on investment.
Well, I think both. I mean, it'd be fantastic if information from their peers can become public. But definitely what we do when we try to publish results, we try to do it so that the information is publicly available. And so that's, I think, more realistic. Although for sure, there's companies that have and are very open in sharing that information. I'd say it's a little bit of both. But most likely from us, that's essentially the priority that we need to focus on in our future researches and trying to demonstrate the economic feasibility of using the systems and potential economic benefits.
Sure. So another question that I got here, can you talk a little bit more about the dome setup in URC? How does this affect the lighting received by the cuttings and temperature settings?
That's actually very interesting because we're using that both in the carts, and then we're using that in our current light quality experiments, just because so how does it affect temperature? We have thermocouples inside, and so essentially we just regulate the environmental chamber temperature to make sure that what's being measured inside the domes is the set point that we really want, which again may be slightly different from the set point that we have our chamber. And the reason we decided to go with domes is at this point we haven't quite figured out what's the best method to provide that humidity for growing these plants in these indoor environments. We've had challenges with the lightings that we're using and just having too much fog and having that lamps died on us. So we decided that for the purpose of the research we're doing now, the domes work very well at maintaining that high humidity in the microenvironment, but keep it away from our sensors. And so until we can actually come up with a better system, and we now have a controlled environment engineer who's collaborating with a lot of the research, so hopefully we can come up with a better solution. But for now, we're more focused on that microenvironment inside the domes.
Perfect. You mentioned the lighting management as one of the key aspects pointed out by the growers, one of the challenges or the points of interest. Could you talk a little bit more about that, Selena? When they say lighting management, did they specify if they're looking for the impacts of the spectrum, if they're looking for intensity? Are they worried about the efficiency, so the cost of lighting? Can you tell us a little bit more about that?
I think it was not, I don't recall the cost of the light fixtures coming up, it was all about both light quality and light intensity. And when referring to light intensity, the questions were, well, how much light do I need? I mean, I don't want to provide more than what I need. And that goes back to the last slide I showed you. I mean, these plants may not necessarily be able to make use of a whole lot of light, at least initially. So there needs to really be a good understanding on how much can they tolerate so that we can minimize what we're giving. We're not necessarily trying to give it too much light. We're trying to find, well, how low can we go to actually maximize that growth and development of these young plants, and to maximize the economic cost of providing that light. And then there was also a discussion, and that's discussed in the paper, that the light intensity effects will also ultimately have an indirect effect on things like temperature and other environmental management decisions within this indoor system. So it really all interacts with each other. And then with regards to light, yes, I mean, there was just general questions about light quality, which are all very, very interesting. And I think a bit more challenging to address because, I mean, we've seen it over the last few years that light quality responses sometimes are species, sometimes are cultivar specific, and thus it becomes challenging. So how do we find something that optimizes pretty much everything, that works well for everything? And that's part of the reason why we're going with white light as a background, really.
Right. Yeah, that makes completely sense. And a good segue for this question is, besides what you just mentioned, having these different species, just now growers are growing different crops. They have different setups. There are different like fixtures out there. Did they tell you, are they willing to do some trials internally? Have you come across growers doing internal trials? Is that something they could solve? So they do separate a small area and they try different light intensities or different.
Absolutely, yeah. And that's part of the reason why we send them. I mean, maybe they don't want to spend money or can't spend the money in actually investing in this technology. So my colleague Paul was very generous to send them this light cards, and they're all absolutely willing to help us do the research. I think we're right now at a point where we just need to sit down and organize exactly what we need to do to make high quality research, but everyone's willing to help. Yes.
That's fantastic. Is there a place people can contact you? I believe that's done within Florida. Is there a place, if a grower wants to participate or get access to this, can they contact you, or that's already done?
No, absolutely. Well, I mean, yeah, I don't know. They can email me for sure. I'm not sure I can promise that we'll send them a system. But we can absolutely provide information and just start a relationship, I guess. Just if someone is interested, they can just contact me and we can start a conversation.
Yeah, that sounds a good way to potentialize and multiply the knowledge. So then you can tackle many people at once. So
Yeah.
One more question coming here. That's a nice one as well. Do you think that spectrum adjustment could circumvent the anthocyanin production while still allowing the highlight intensity and therefore still generating the increased biomass seen in the blueberry experiment?
We actually just saw that. I mean, 3 days ago, I helped my student harvest his plants because we're a little bit short-staffed at the moment. And it was clear that one of the light quality treatments that we're using does not have that anthocyanin accumulation versus a few other treatments. So yes, now the answer, the question is, well, is that really going to lead to a higher yield or a higher biomass production? So we'll just wait and see the results at the end of the trial. Right now we just had our intermediate harvest. We'll see how the plants respond at the end of the 8 weeks. But yes, there's a lot of potential, I think.
Sure. Fantastic. Well, Selena, we got to the time. It's 2:00 right now. I think we could fit exactly 1 hour.
Perfect.
Thank you so much for presenting. That was a great presentation. Lots of data. That was very good to hear the stakeholder information for these meetings, plus all the information from University of Florida. Anything else you'd like to mention to the audience? Maybe your contact, how to find you, anything else you'd like to leave? Any final thoughts?
Sure, my email, because I guess I should have included it, but my email is cgomezv@ufl.edu. And by all means, if anyone has any questions or comments that they would like to follow up with me, I'd be happy to go over those. And that's it. Just again, thank you, because I know today's a very busy day for everyone. So
Yeah, well, it's fantastic to have you here. We have, this presentation will be recorded, so we're gonna be uploaded to the Glaze website. We always get upcoming questions after that, and I'll make sure they get to you if people want to learn more about this. Thanks everyone for joining the webinar today. Again, thanks again, Dr. Gomez. It was a pleasure to have you here,
absolutely.
and I look forward to the next meeting.
Thank you. Bye, everyone.
Bye. Have a good day.
You too.